Hi, my name is Junko Yoshida. I'm Chief International Correspondent of EE Times. I'm here today with Michael Barr, who just finished his keynote speech at EE Live. He just had this really great presentation that entitled Killer Apps, Embedded Software's Greatest Hit Jobs. And he actually talked about various problems the industry or the whole world had witnessed in terms of the Patriot missiles, the incidents, also the radiation equipment that's called
Therac 25.
Therac 25, and also he mentioned something about the automotive, including the Toyota electronics software issues. But anyway, I would like to ask Michael, several questions based on today's presentation. I think today's presentation, you talked actually a lot about testing. In other words, what struck me most was testing cannot prove absence of bugs or gaps, right? And you actually laid out in each case that was the case. And you talk about not only the time of how long you do the testing, but also the types of testing that really didn't hold up at the end. Can you tell us a little bit about what is really needed for the right testing?
Right, well, I didn't mean to suggest at all that testing is not important. Testing is very important, and
Right.
particularly regression testing to make sure that bugs that have previously been eliminated haven't cropped back up. But what is very important to realize, and all engineers need to be aware of, is that testing cannot prove the absence of bugs, no matter how many hours you've tested or how many kinds of testing you perform. So it is very important to test, but more important is to design a system that cannot fail, so that if the software fails, the electronics and the mechanics around it protect the user, protect the environment.
Right. So in other words, testing is important, but testing itself cannot be the assurance that your system will not fail.
That's right. We see time and time again when for example, we talked about the Therac 25 and the Patriot missile failure in 1991, and in both cases people said, well, we did a lot of testing, and they named how many hours of testing they had done. But in hindsight, the lesson was they had software defects, and those software defects were lethal. And so counting the number of hours of testing, even the kinds of testing, is not sufficient. You have to do what's called functional safety. You have to build a safety case, and these techniques are not, we're not inventing these. These techniques exist and have existed for some time, and it's a matter of applying those. And that's one of the things we help people do at the Barr Group, is we help companies to make their systems safe, reliable, and secure from the start, from the design.
And another thing actually struck me is that systems of fail-safe, has some, a lot of times it could have holes. To design a fail-safe system seems to be particularly difficult for the embedded software. Is that the case, or?
Well, designing the fail-safes is something you have to do from the beginning, and you have to make sure that you've properly accounted for everything. Unfortunately, in many situations, the engineers end up adding this on at the end. So they get the products to work, and then somebody says, well, we should have some safety, and they add a layer of safety. And the problem is that you can't imagine all the things that can go wrong in a very complex system.
Right.
And so you can't think about it that way. You can't add in the safety later. You can't just have a haphazard system of fail-safes.
And actually, you did actually tie this together at the very end of your slides. But I just want to ask you one thing. You showed that slide of Google car, self-driving car, and it sort of makes us wonder that the world we are getting into with all the software in automotive, and at a time that we learn that automotive industry doesn't have software oversight or regulations that are equivalent to that FDA has or FAA has. Do you envision such regulations or oversight, software oversight, will actually need to be introduced in the automotive industry?
It absolutely has to be introduced.
Yeah.
I hope that it's just a matter of time.
Yeah.
It really needs to be done because, if you think about it, the car industry is a mechanical industry, right? Mechanical engineers made cars, and they were mechanical things. And this, 50, 100 microprocessor networks of computers in the modern car, the car industry has been sort of dragged into this business, and so they are trying to apply, lessons learned from manufacturing 1 million trunk lids a year. Those are not the same lessons as building safe software. And the NHTSA, the regulator, is in the same situation. They have traditionally regulated wheels not falling off, and instead now they're regulating, or you know, tire pressure issues and things of that sort, rollovers, mechanical stuff. And now the cars are, the value in the cars, the safety in the cars, increasingly is software in electronics, embedded software. And you can't have a business that's like that, particularly as Attorney General Holder said in the DOJ settlement with Toyota, cars are inherently dangerous products. And so the designers of cars need to be held to a higher standard than the designers of digital watches. And it's, I hope, inevitable, and hopefully quickly here, we're going to have proper regulation and oversight, informed oversight of software in cars.
One last question, I just thought of it. Are you looking forward to these self-driving cars one of those days?
I hate driving, and I really want a self-driving car, but it makes me nervous at the same time.
All right, thank you very much, Michael.
Thank you.
It was great.
It's great.